just gonna walk through some problems before ending this video. I guess I was concurred during the last video, so I'm just gonna walk through some problems. Maybe give general devices and tips in the following cases. Yeah. So, uh, first of all, the first question is the functional equation. I guess here what we can essentially do is uh, give a substitute here. So let's say uh, a is 1 and b is 0. Then we have our function 2f1 equals 2f1 squared, 2f1 f0. But then we just simply multiply by some constant, and then I guess 2f0, we can divide both sides by 2f1. We can divide both sides by 2f1, meaning that there's some constant to 1. The constant left here is 1. Well, let's say a is 2 and b is minus 1. No, let's say a is 1 and b is minus 1. Then we have that f of 0, which is just 1, plus f of 2 is equal to wait is equal to f of 2, f of minus 1, f of 1, f of minus 1. Now we know that f of 0 is equal to 1, meaning that for any function, let's say of degree sum a to the power of n, we have that some variables there are actually plus 1, meaning that the constant here is 1. So we can actually substitute in this answer and then maybe find the values for this each particular case. Just substitute here. So yeah, that's I think the general advice I would give to the problem. This I think for an AMC, especially when you don't have much time, this is actually really useful to know those lemmas. So I would suggest doing that. Then, what should you do? Not this one, right? This is gonna be a homework. Okay, let's do this one then. So here, I think the main theory is that you should remember Euclid division algorithm for polynomials in such a case. Uh, in this case, if polynomial x, so here we can also what we can essentially do is if you have some polynomial of degree n, we can actually multiply that. There remains 2x plus 1. Okay, so we can actually we don't actually know what actual degree this is, but we can just substitute. Okay, we can find the roots of unity here. The roots here are plus minus I, then plus minus I, which clearly doesn't work. So we need to find some existential lemma that helps us determine this particular case. Oh, yeah, polynomial must be degree 2 or more. Let's find the squares of the polynomial. We'll actually find the roots of this polynomial and then substitute here, and then it gives us this polynomial. Then we can actually substitute it here to actually find some degrees there, which is helpful here. That's why I would give a general advice here is just to revise here, and I think find the concurrent lemma here. So yeah, I guess. Okay, for a positive integer n, let Rn be the sum of remainders when n is divided by 2, 3, 4, 9, 10, 10. For example, R15 is just 1, 0. Okay, uh, how many two-digit positive integers satisfy Rn is equal to Rn plus 1? Okay, I guess this is an interesting lemma. Although I think this is quite impossible, since from two-digit positive integers, we need to have equal number of divisors, I think, in some sort, such that the remainder is the same for some of the divisors, meaning that let's say just compute from 1 till 99. So let's say 10 and 11. 10 and 11 aren't necessarily a good case here, because 11 is a prime number, so it cannot be divided by this. So we can actually use C-various losses and cancel out all the prime numbers here. So all the prime numbers from 1 till 100 include 1 till 100 include 11. Let me just type that, right? Powers of 2 doesn't work. Powers of some number 2 doesn't work. Since when you're working with powers of 2, I think the interesting lemma is here that they're essentially the same. So powers of 2 cannot be corresponding to powers. So 11, 11, 13, uh, 17, 19, 23, 23, 20, no, 23, 25, no, 29, 31, 33, 30, no, 35, 37, 41, 43, 47, 51. And the pattern continues here, I guess. So all those problems, prime numbers doesn't work. Then for Rn plus 1, here interesting lemma is that if n is odd, then if n is odd in particular, especially two-digit numbers, they're gonna be divided by this same number. So when you find some integer such that it's 3 times 5 times 7 times 9, all of these concur, and 2 times 4 times time. So 1, 2, 3, 4, 1, 2, 3, 4. So once you it necessarily don't need to be the power of 10, but I guess this is an interesting to see. So we can find some, okay, so it should be a power of 10. So then here we can multiply 2 by 4, which is 8, 8, 8, 8, 8 by 6. This clearly doesn't work. So we need to find a way how to multiply the powers of 2 and powers of 3 so that we can get modules here. So I will guess it's really helpful to find some numbers here. And I think it doesn't really work here because once you congruently interpret all the factors, doesn't apply here. So yeah, I would guess the best suggestion for this problem is just compute all the, maybe find some irrationalities and compute the following sums. Yeah. So bye. I guess this been helpful. You can actually go to the art of problem solving and then help reduce the problem yourselves. Yeah.